Engineer in KSEB Limited, Honorable Director of Center of Excellence in Engineering and Business Administration and Chief Editor of Heidel Journal, and Ms. Geethu R.S., currently serving as Assistant Professor in Department of ECE at Amrita College of Engineering, Amritapuri, and pursuing her PhD in VLSI testing. Next, I would like to welcome our guests. Ms. Pratibha P.K., Chapter Advisor, IEEE PES SBC, Rajagiri School of Engineering and Technology, Kochi. Engineer Hasina P.Y., Counselor and Advisor, PES SBC, IEEE Student Branch, College of Engineering, Karunagappally. Ms. Nimida Muralidharan, Chapter Advisor, IEEE PES SBC, NSS College of Engineering. Ms. Gomadi S., Chapter Advisor, IEEE PES SBC, Adi Shankara Institute of Engineering and Technology. Now, last but not the least, I would like to welcome all our participants to this session. Once again, welcome you all to this gathering. Hope you all have a wonderful time ahead. Thank you.
Thank you, Shruti. Thank you for welcoming everyone present here.
Let's move on to the most awaited session of the day. We are honored to welcome Professor V.K. Damodaran sir, a teacher with years of experience behind him. His accolades include Life Senior Member of Indian Institute of Engineers, Life Member Coordinator of Region 10, Indian Council. He was in the Indian Council newsletter for 10 years, and Indian Council Executive Vice Chair of 2001, and the position held section newsletter editor of the Kerala section chairman, 1991, and he was advisor of Young Professionals Goal 2011 to 15, and he was a government license chair 2017-18, consultant network chair 2020, general chair 2021, and he was in the various subcommittees of EAP 2012-17, and he was a member of MGA Life Member Committee 2017-18. Various awards and recognitions has been included in his bio. 2014 EAB Global Meritorious Achievement Award, 2012 Recent and Historical Achievement Award for Innovations in Renewable Energy Applications for Remote Rural Areas of Africa, 2003 Millennium Medal for Outstanding Volunteer Award. In 1999, Management Leadership Award of Trivandrum Management Association and Gold Medal.
Okay.
So it's with immense pleasure we invite Professor V.K. Damodaran sir to the inaugural note.
Thank you, and good afternoon, one and all, from the fraternity of PES Kerala Chapter, especially of the student branch members, their advisors, and chairs. Let me first of all express my gratitude as well as great pleasure in participating in this event, at least for a short while, mainly because reason one, I've been one of the founder members of the PES chapter in Kerala. And number two, I've been one among the earliest members of IEEE from Kerala. That is why I happen to be the life senior member, one among the life senior members of IEEE. Well, that is one thing apart. Today's event and my remark, which will be very short, is basically on your effort here to experienced power engineering and energy engineering professionals are trying to tell you today how to lead your mandatory projects to success. That will be a great thing to get a guidance like that. None of us ever got that kind of a guidance or even a hint about success and failure in projects when we all did it decades before. That was the technological advice scenario in Kerala or in India in general. Well, coming to this issue, I would first of all tell you that there is one more reason why I am very happy to address you today. In the late 1970s, while I was still teaching in the present NIT Calicut, the erstwhile Regional Engineering College of Calicut, I had actually strongly argued for an intervention by experienced professionals in shaping the student projects which were mandatory even then. And in that, it was not very much appreciated. Many people used to actually do some projects which will be a dissertation on a particular topic, which may be an advanced one, or it could be doing some little experiment on something and trying to get some data. Finally, extrapolate or interpolate them and come to some conclusions and just learn the method of research. But beyond that, at that time, what we did was, I think first we did it in REC. Later, I think we did it in NSS Engineering College, Palkad. Those days, there were only 6 engineering colleges in Kerala. And I think one more place, Trichure Engineering College, which of course happens to be my alma mater for my first degree, the first batch of Trichure Engineering College. So in these workshops, what we did was we used to have in the evenings a brainstorming session with students, some of the interested staff members, and some professionals outside the college purview who are actually interested in students undertaking projects which have some relevance to society or life in general. And we used to prepare out of these brainstorming sessions a list of projects, then try to reiterate them and shortlist maybe some 30 or 40 project titles and circulate it among the students so that they can, those who are interested can pick those projects and do. Why we did that was 40% of the success of your project is in selecting the right field of work. So unless you are zeroed in on or within that kind of a field, your project will be 40% fail. The next thing is, next 30% of success, I would say, with my experience in doing projects as well as guiding projects and sometimes even suggesting projects to be done by others, is how you focus the major or the main problem in that area. So you have to slightly tilt the mirror so that you get a clear focus on some, even it can be even a very small area. Into that small area, if you can focus, 30%, the next 30% success element is guaranteed. And your perspiration has only the remaining 30% angle. And in that perspiration, it also includes the perspiration of the guides who will be looking after your projects. So that is why I attach so much importance for selecting the right field as well as the focusing a problem very correctly, and that should, as far as possible, should have certain social relevance, should have certain futuristic view and opportunity to do a lot of things, kind of uh, pushing around a number of bushes and finally getting the rabbit out. So that's all I have to say. And I was luckily, I will actually close with this remark. In 2013, when I went to San Jose in California, USA, for an HAC conference for making a presentation, there an invited lecture was given by the Dean of Engineering and Technology Faculty of the Stanford University, which is very well known, like MIT, for their successful projects and the guidance to engineering students and professionals into worthwhile, earth-shattering, or what you even say, uh, change-making projects for the whole world. So these two are actually very well known for that. Not that other universities are not anyway good at it, but so after listening to him, I thought of next day I went to Stanford and I had sitting with him for a number of minutes, almost I think 1.5 hours. And what I could gather was that they also felt that the engineering education was becoming less and less relevant, even for the students who study there. And therefore, the admission rate was actually going down. Then they conducted a national survey. And what that survey found, brought out was that the students who have passed out and finally entered jobs elsewhere, they were actually complaining that we were never trained or given an opportunity to solve a problem during our 4-year career in the university, or in any university for that matter, here as well as there. And whenever they enter a job, they are actually given a problem to solve as far as its total meaning is concerned. And they used to find it very difficult to be successful in their career. So Stanford actually changed into the curriculum and syllabus, made it a little bit flexible. And they said every student will have to pick any problem. It need not be the subject which they are studying. Any problem which they feel interested. And during the 4 years, they will have enough time to pursue this project, learning new things, doing certain things. Finally, at the end, they have to actually solve that problem before they get their degree. And this made enormous change in attitudes to engineering education in the whole of US and especially under the umbrella of Stanford. So the lesson is, if you have a worthwhile, meaningful project focused on getting your ability to solve the problem well developed, at the same time, you are solving a problem which is relevant to the contemporary society or for the future society. This is actually very important. And I think the lectures and examples that the two speakers today will be giving to you will actually elucidate these points and probably support and strengthen this argument that the project execution in our universities should change much into a much better position than how we take a project now. And the last word is, you are trained today for doing your project successfully. That's a great thing if you can. But in any research, in any project, you should always expect failure. Failure is also a lesson. Therefore, in an engineer's experience, failure of a project and success of a project, in between, the distance is very little. But if you always expect that failure is around the corner, that is actually the best alert that you get for your mind to always drive yourself towards success. And I hope after this workshop, the kind of projects that you churn out in the current year will be a path-breaking scenario in the engineering education of Kerala. With these words, I'm having immense pleasure, which I express in inaugurating this special workshop. Thank you.
Thank you, sir. Thank you. It was an eye-opener, and I'm sure that it provided us with ample knowledge and opportunity. Thank you.
Thank you.
Now, let me welcome all the chapter advisors of our colleges who have always been a constant support guiding us throughout this journey. I invite all the chapter advisors to do the felicitations for the event. Let me start with Ms. Pratibha PK, Chapter Advisor, IEEE PES SBC, Rajagiri School of Engineering and Technology, Kochi. Ma'am, please.
Okay, good afternoon, everyone. I hope I'm audible to all of you.
Audible.
Yes, okay, thank you. We are really honored to host such a great event organized by IEEE Power and Energy Society Kerala Chapter. So first, let me thank our IEEE Power and Energy Society Kerala section for giving such an opportunity to us. And happy that we are able to get a very good number of registrations from EEE, CSE and ECE department students. Today, we have two eminent speakers with us, Dr. Krishnakumar sir and Geethu madam, and I hope it will definitely throw a light on successful execution of BTech projects even under this pandemic situation. BTech projects can also turn out to be your career option. So I wish all the success to all the participants and hope to see more glorious events from IEEE Power and Energy Society student branch chapters. Thank you all.
Thank you for your words.
Okay.
Hasina PY, Counselor and Chapter Advisor of PSSBC IEEE Student Branch, College of Engineering, Karunagappally.
Am I audible?
Yes, ma'am.
Respected PK Damodaran sir, other dignitaries, the resource persons Krishnakumar sir and Geethu ma'am, and the chapter advisors of various colleges and dear participants. Actually, we are having the session or the workshop on how to execute successful.
Feeble ആണ് അല്പം കൂട്ടാൻ പറ്റുമോ ഒരു അടുത്ത സംസാരിക്കുന്നു.
Yeah, okay. Yeah. Hello, is it clear?
Yes, ma'am.
Clear,
Yeah,
ma'am,
okay.
but
Actually,
കുറച്ചുകൂടെ louder.
yeah, it is. Yeah, okay. Yeah. I am glad to have a felicitation for this workshop conducted by the IEEE Power and Energy Society Kerala section, and it's the third edition of this program. And actually, as we are having at the position of engineers, every BTech students should be faced by the question. Everybody says that the project is very important. Why this question arises? It is because we cannot say as an engineer unless if we can really build things of our own in an engineering level. And if we are attending interviews at the freshers level, and the questions will be mostly concentrated on the projects we have done. Therefore, in order to have a successful project, we should have our own contributions for the completion of that projects. Okay, and apart from the theoretical knowledge gaining from the different courses we are studying at the BTech level, we'll get more practical knowledge from the projects we are doing at the BTech program, and our involvement will be more in doing projects. I am sure that the sessions handled by Krishnakumar sir and Geethu ma'am will surely guide to execute a successful BTech project. And I take this opportunity to congratulate IEEE Kerala section and selecting our college as also the host for conducting this session. And I wish all the success for this program, and I request every participants to grab this opportunity and make the fruitful knowledge out of this. Thank you.
Thank you, ma'am. Thank you for your wonderful words. Next, I invite Ms. Nimida Muralidharan, the Chapter Advisor of IEEE PES SBC NSS College of Engineering, Palakkad.
Hello, am I audible?
You are.
Yes, ma'am.
Okay. Very good afternoon to our Honorable Chief Guest, Professor V.K. Damodaran Sir. Speakers of today's event, Dr. Krishnakumar and Professor Geethu R.S. Staff advisors of co-hosting PES student chapters, Professor Gomadi S., Professor Pradhiva, and Professor Hasina, and one and all present here. It is high time that we can hear rising cries for improving the quality of engineering students every year. Without any doubt, we can say that the BTech project is one such course that the student learn the most from in these 4 years. And it is also equally appreciated by the faculty and the industrial community throughout their career. So executing a project successfully is as much as an art as it is the engineering. Therefore, I would like to thank the speakers of today's event for taking time to deliver a talk on such a beneficial topic. Also, I would like to thank Professor Damodaran Sir for inaugurating this session and also guiding the students regarding the importance of BTech project. I'm absolutely sure that everyone gathered here would be benefited tremendously. Thank you.
Thank you, ma'am. Thank you for your words. Last but not the least, I'm welcoming Gomadi ma'am, the Chapter Advisor of PSSBC, Adi Shankara Institute of Engineering and Technology.
Aditya, am I audible?
Yes, ma'am.
Okay. Good afternoon, respected Damodaran sir, and SBCs from other colleges who are known to me also, and Bobby Phillips sir, and the chairperson, secretary, and all position holders of this IEEE PES section. A very good afternoon to one and all. So actually, I was having this topic telling to my students to organize a very good workshop. Actually, I want to make it hands-on workshop actually, but due to this pandemic situation, I'm very happy to see that at least it is happening virtually. So one thing, when I interacted with the students, even alumni, I could understand that practical sessions or the practice by executing a particular project the student is having is lacking nowadays. So everybody, what they do is that they will outsource the projects to some other person and somehow get it done. But it should not be like that. So for that, you have to find out what are the current recent researches which is happening around you. A lot of things are happening in renewable energy sector as well as electric vehicle. Even a very good challenge is in developing a wireless charger for an electric vehicle. Already it is there, but a good one which is having a good efficiency and with the least time charging. So like that, several topics are there. And moreover, to reduce the gap between the industry and institution, it is very important. So earlier, students were who got placement in certain companies, they were given placement training. Even after getting placement, they were given training in the particular companies so that they will come to know what all happening in a particular industry. But now the situation has changed. So right when they pass out from the college itself, they must be able to execute a project which is given to them without any support of others. Because in our early days, we were not having such resource materials to enhance our knowledge like in this situation. So whenever we want to enhance our knowledge, we have to go to the library, physically go to the library and get one book. By reading that book only, we will be able to, study about what all things which can be done in this particular project. But now the situation has changed because resource materials are available everywhere and a lot of open source platforms are there. So the students have very good chance to perform well, but still I am finding that students are taking it very easy. So my advice to you is that grab the opportunity of executing a project in the BTech program, which will entirely change your career. Definitely your project decides your career. That is very important. That keep in your mind. So do the design project as well as whoever the students maybe in the first, second year, third year also must be there. So design project also you do it very well and get it patent. Somehow you study what all the design aspects are there in a particular item and then add on your innovation in that and convert it to a new product, apply for a patent. You can start up, you can very well start up an entrepreneurship, startup firm of your own, and by 3 or 4 group members together, you can run the industry. So rather than seeking a job, you must be able to provide job to others. Okay, so with this mind, your 2 well resource persons are there. I'm very glad to see that we got just one person from academic as well as one person from industry. So those speakers will be having a lot of things to tell you. Listen to that and take home with the positive things which are being told to you, execute it and make your project a very successful. Thank you. Thank you very much for giving me this opportunity to interact with you. Thank you. Thank you very much.
Thank you, ma'am. And once again, thanks to all the chapter advisors for your inspiring words. Thank you.
Next, I invite Riya, current chair of College of Engineering Karunagappally, to deliver the vote of thanks.
A warm and graceful day to all those who are present here. It's my privilege to have been asked to propose a vote of thanks on this inaugural session on behalf of the PES chapters of College of Engineering Karunagappally, Rajagiri School of Engineering and Technology, NSS College of Engineering, and Shankara Institute of Engineering and Technology. First of all, I would like to express our sincere gratitude to our chief guest, Professor V.K. Damodaran sir, for inaugurating this session and gracing the occasion. It's an honor for us that you have been here with us today, sharing your valuable findings and opinion. Thank you, sir. Now, I would like to extend our thanks to Ms. Pratibha PK, Chapter Advisor of IEEE PES SBC, Rajagiri School of Engineering and Technology, for your presence and support on this occasion. Thank you, ma'am. Now,
I would like to express our gratitude to Engineer Hasina PY, Chapter Advisor of IEEE PES SBC, College of Engineering Karunagappally, for your guidance and encouragement on this occasion. Thank you, ma'am. Now, I may like to express our sincere thanks to Ms. Nimita Muralidharan, Chapter Advisor of IEEE PES SBC, NSS College of Engineering, for your support and cooperation on this occasion. Thank you, ma'am. Now, I would like to acknowledge our gratitude to Ms. Gomati S., Chapter Advisor of IEEE PES SBC, Adi Shankara Institute of Engineering and Technology, for your presence and encouragement on this occasion. Thank you, ma'am. Next, I must mention our deep sense of appreciation for the PES chapter co-host of College of Engineering Karunagappally, NSS College of Engineering Palakkad, Adi Shankara Institute of Engineering and Technology, and Rajagiri School of Engineering and Technology for their enormous cooperation in the organization of this event. I would also like to extend our thanks to IEEE PES Kerala Chapter for providing us this opportunity in organizing this event. Finally, I would like to thank all the attendees and volunteers who are here with us today for your presence and involvement. I hope you all have a very informative and insightful session ahead. Thank you.
Thank you, Ria.
Okay. The highlight of today's session is the eminent speakers who have showed up to enlighten us on how to execute successful BTech projects. We are honored to have these speakers with us for this session. Without any delay, let's welcome Mr. Krishnakumar and Ms. Geethu to take the session. First of all, Dr. Krishnakumar M has graduated in Electrical and Electronics Engineering from TKM College of Engineering and has got the MTech in Computer Science from CUSAT. He got the PGRM from University of Kerala and PhD in Hybrid Signal Processing from CUSAT. Started career as electrical engineer in Hyundai Engineering and Construction Company. Has also got the 10 years of experience in academia and 12 years in the industry. He got professional experience in the construction of 60 megawatt Pallivazal Extension Scheme Hydroelectric Project, small hydro station, Sengilam Pump House, construction of 245 kilowatt GIS substation, and maintenance of power equipments, etc. He has in his credit 10 international research publications and is currently working as the engineer in KSET. Honorable Director of Center for Excellence in Engineering and Business Administration, and is also the Chief Editor of Hydel Journal, etc.
And the other speaker is Ms. Geethu R. She is the Assistant Professor, Civil Grade, Department of Electronics and Communication Engineering, Amrita School of Engineering, Amritapuri. She also has 15 plus years of experience in teaching. She did her MTech in Microelectronics and VLSI, NIT Calicut. She also has been credited Best MTech Project Citation. Currently, she is pursuing her PhD in VLSI testing. Received fellowship for 3 consecutive years for International Test Conference India. 17 research publications, mostly scopus in tests, has been in her. Also the founder and CEO of startup company Right Button Labs. Fellowship was received for Tikon Rebuild Kerala and Tikon Women in Business International Conference. So without further ado, I invite both the speakers to take up the session.
Hello all, hope I'm audible.
Yeah, ma'am, you're audible.
Thank you for the kind introduction, Ms. Ria and Mr. George. We feel honored to be present here with Professor V.K. Damodaran sir. And I would like to thank all the host and the co-host of IEEE PES SB chapter, Ms. Pratibha P.K., chapter advisor, Rajagiri College, Ms. Hasina P.Y., Chapter Advisor, College of Engineering, Karunagappally, Ms. Nimita Muralidharan, Chapter Advisor, NSS College of Engineering, Palakkad. Ms. Gomati S, Chapter Advisor, Adi Shankara Institute of Engineering. Let me share the screen. Hope the screen is visible to all of you.
Yes, ma'am. It is visible.
Okay, so without any further delay, we will start with the topic today: students' projects, innovation, prototyping, and social impacts. The outline of the talk will be introduction to academic projects. So before starting, we would like to assume that we have a mix of audience, students from first year to final year of your engineering course. So because since we are assuming that some of the things may be very familiar to many of you, like what is a many of you, but few topics which will the junior students who are not so familiar, like the projects, what is meant by an innovation, then how do you make a report. So we basically our talk will be targeting first years to fourth year students. So the outline will be introduction to academic projects, innovations in projects. What do you mean by prototyping? Then how to prepare project reports. What are the different ways to find a project? Then creating social impacts with your idea, because social without a social impact, your whatever you have learned in your engineering course is not of a use. So we believe in that. And finally, we will be concluding with the best practices. So with these words, I would like to hand over to Dr. Krishnakumar N.
Good morning, all. So we'll start with what is a project and benefits and learning outcomes from project, types of projects, that is hardware, so projects, software, project and research type of projects, and how the projects are evaluated. See, there is a difference between academic projects and industrial projects. We are mainly concentrating on academic projects because our today's agenda is on students projects. So we'll also bring into some key ideas of industrial projects. There is a difference between industrial project and academic projects that I will discuss later in slides. So we'll move to the next slide. So what is a project? So most of us are hearing the term project in everyday life as a government executed project, private project, students project, etc. Then what is a project? There is a definition: effort to create, modify a specific product or service or result is a product. So it's a temporary thing. Project is a temporary work effort with a clear beginning and an end. So a project has a certain time, that is, it has a beginning and it has an end. It is temporary also. If it is a permanent nature, that is repetitive nature, it is not a project. It is become a production line or a maintenance activity, etc. So a project means it's a temporary activity. It will begin and it will end, and we will get a product, service, or result, whatever. So the main two features of projects are is temporary in nature. That means, as I told, it has a finish date and an end date. Then it is unique. So every projects, each and every projects are unique in nature. So we cannot tell that project 1 is equal to project 2. No, there will be at least between in any phase of this project or product of the project. So every project is unique in nature. So that is the challenge in executing a project. So we'll come to project attributes. So a project is as I told, project is a temporary endeavor undertaken to accomplish a unique purpose. So we have a goal to achieve in a project. So the main attributes of a project are It has got a unique purpose. It is temporary in nature. It requires resources, often from various areas. Because for a student's project, what are the resources we require? We require team members, it's a human resource. We require a mentor, it is a resource. Mentor time is a resource. You want maybe computer, you may require a hardware. You may sometimes want money for doing the project from your home or from your college or from other funding agencies. These are all resources. So next is for a industrial project, you are a primary sponsor or a customer. So usually in academic project, we do not need a customer, but please keep in mind it's a good practice to build a project or build a product for a targeting a customer. So the most important point is, in every project involve uncertainty. Every project involve uncertainty. So this is very important. Keep in mind that a smooth execution in a project is a dream. You cannot execute a project, BTech project, MTech project, or PhD thesis, or any other work, or industrial project, or government project. The uncertainty is a part of it. There is uncertainty. So there are different phases of a project. So what are the different phases of a project, and what is the project life cycle? So every project will begin and will end. So from the beginning to end, it is called a project life cycle. So project life cycle is a collection of different phases. Please keep this in mind. In your BTech project also, you require different phases in project. If you are executing your BTech project in phased manner, you will get a better output and a better documentation output. So a project life cycle is a collection of project phases. So project life cycle generally define what technical work should be done in each phase. But in the case of project management life cycle, you are involving the management function to this project life cycle. So project phases vary by project or industry. See, there is a different every in most industries, they have their own style of project life cycle. They will define their own project life cycle, their phases, their project phases, etc. Suppose in my company, it's a government-owned company. In my company, there is a typical style of project execution that we'll discuss if time permits. So in a private company, if company B or in Infosys or in other company like in CTS or any other company or in Cisco, there is a different style of executing their project, their own project life cycle. They will choose an existing project life cycle, or they may build their own project life cycle. So anyway, we in beta project we can follow a very simple project life cycle, that is a waterfall model, as I mentioned here. So project life cycle involves definition and conceptualization and planning and budgeting. Budgeting may not be much important to a BTech project. Anyway, we are going to build a product with it's an expensive project. You require budgeting also, some sponsor from your college, from your home, or some external agency. So we have to develop and implement, and finally there is a termination and cross out of the project, and there will be a project presentation. So we have a conceptualization and initiation of the project, definition and planning, execution phase, then some control. If anything happens, we have to rethink of project design and other things. Then we'll finalize, close the project. So next is philosophy and aim of the project. So in a project, see, your students are thinking why a project is involved in a curriculum, in a university curriculum. Because see, you are studying in a professional course, and you are supposed to work in industry. See, we are also product. I am also a product of an engineering college. Like you, after 1 year, 2 year, 3 year, you will become an employee of a company or a government firm, or maybe make your own, start your own company, whatever. Anyway, so the importance of project in a curriculum we'll discuss in this slide. Project is a student-centered approach, mostly a student-centered approach, because students have got their own control on project, so they can decide many things of their project. So a student then a project will help students to acquire deeper knowledge through active exploration of real world challenges and problems. Apart from your curriculum, that is a curriculum is very definite, and your subjects are subject and textbooks are usually prescribed in a black and white manner. You have to follow that, and but in project you have a lot of what will tell lot of independence, or you can do whatever you want, means in a limited sense you can do a lot of things in your project. So it is learning by doing. So this project is intended to aim to bring the attention of students in a real world problem. This will help in their future job. So the next point is to the project will help to provoke serious thinking as students acquire and apply new knowledge in problem solving context. So this project will help to train the student in problem solving, because in industry every day you will get challenges in problem solve. You know, new problems will come in before your desk and you have to do it. So project also will help to acquire new skills. So a skill, as you know, skill is an ability to do something well. So the last point is teacher plays the role of a facilitator only. See, so this I early mentioned that it's a student centered approach, and the guide, the teacher or the guide, or maybe internal guide or external guide, their role is very limited, and they will help you to execute the project, and they will share you the wisdom. So this also will improve your soft skills, as you know, aware that we have technical skills and also soft skills. So soft skills like critical thinking, problem solving, collaboration between group members, and various forms of communication like written communication and oral communication between your group members, and written communication like project reports and other things to the teachers, or present before a panel, etc. Presenting a PowerPoint presentation or any other type of presentation before a panel or before the audience. This all will help to improve your soft skills and also the personality. So it allows some degree of student's voice and choice that I earlier mentioned. So this also will help us to study a soft skill, that is feedback and revision. See, ability to take feedback is very important in the personal skill. So we should be open in our mind to take feedback. If it is negative or positive, you have to appreciate the feedback and incorporate in the project. So the results are in a see, the results of a project is a product or a paper or whatever you want. So result in a publicly presented product or performance. See, this will give you a satisfaction that your final product is exhibited or presented before a panel, presented before your colleagues, presented before your juniors, etc. This will give a work satisfaction, and seeing your product is working very nicely is see something like a very good satisfaction, I think so. So what are the benefits you are getting from projects or learning outcomes? So you can build a personal relationships among the project group. This is very, very important in industry. See, in most of the industry, other than research industries, very research industry, engineers require colleagues and team. Without team, an engineer will be a failure. Without a team spirit, an engineer will be a failure. Without a team, you cannot execute task in engineering jobs. But in limited, in research and other some academia, it is feasible. But in most of the engineering jobs, you require colleagues, means you have to work in a team. That team spirit is needed. So it will help to build personal relationship, employment related skills. See, like employment related skills. Suppose you are working, you got an opportunity, or you got a campus placement in a company, and the company is executing their work in Android platform. You are doing your project in Android platform. This is initial learning, and your employability is increasing in an exponential manner. So it will help to team and group work mindset will introduce in you, and learn about others perspectives is very important. See, suppose you are a group of 4, these 4 people have their own perspective on problem, and also one social setup and other thing, or whatever things, they are their own perspective. If they don't have perspective, they are not persons. See, all persons have their own perspective. So you should try to adjust with others and also value others perspective, then only you can work in a team. This type of soft skills will be introduced in a project. So share your workload. See, this is very important. See, some people are trying to take the entire work and try to do their own. This is not a good engineering practice. We have to share our workload. If there are 4 group members, you should discuss and brainstorm, and also share the workload among the team members. Then only all can be brought all can be all team members can involve in the project, and they can rise to the level. So this also, as I told, is improve your technical and soft skills. So benefits of learning in groups, we'll continue it. So BTech projects are usually group projects, so 2 to 4 in a team, so at most 5. Usually, I think academia is not allowing more than 5 in usual case. So what is a group? A group is a collection of individuals who come together for a particular reason or with a common name. So learning in group will increase your experience, skills, and knowledge of others. See, we can share the knowledge, share the skill. Suppose person A has a particular skill, like a programming skill, and but a particular person B in a group has like a soldering skill. See, these are skills. Soldering, he can nicely solder. Some other can design very PCB. That person can design a PCB very well. See, this idea can be shared, and skills can be utilized, and you can do a wonderful job. So you can also study how to support others, encourage others, how to take responsibility in a team and share the work, increase understanding and other differing perspectives.
Okay. So, Dr. Krishnakumar has a few peripheral view about the projects. So, since I am from a academic background, I will have a more precise kind of intro to the project. So, how to start with a project? It's like, first of all, as he said, you need to have a teamwork, which means a team should be there, and an ideal group would be members from 2 to 4. So team formation is a very critical part. Then once you have a team, then you should have a guide. Then a guide means, like he said, a guide will be giving a precise view. He will be guiding you only. More of the work will be done by the team members. It's a student-centric approach for the guide, for the project. So there are two methods for starting a project. The first one would be you can form a group, then you can approach a guide. Approach the guide, he will be giving you a problem based on his area of working. You need to understand that area or the problem, specific problem, then you can start working. Now, that second method is you need to be aware about the different technical aspects. I'm from an ECE background, so I would say you need to be aware about or thorough about maybe one or two subjects. Think about the problems one module may have, then you can find out the problems or the innovations that can be done for that module. you, by that way, that team itself can find out a problem. Then you can approach a guide and ask them to guide you. You can tell that, explain that problem. These are the two methods. So after these two methods are done, then the next step would be to approve the working title. You need to have a working title. The title must be approved by the guide, so that it will ensure the enough quantity of work, whether it is fitting in the as a BTech project, whether it can be completed on a given time frame. Those things can be analyzed only by a guide. So even if you are approaching a guide or you are finding out the problem, this is a critical factor, finding out the time and the depth of the work that you do. Then once you have identified a problem, while working among yourself, you should have a project logbook. Ideally, a project logbook is containing all the things that you do related to a project. It can be a very small thing like doing a Google search or finding out a paper related to your project. Then so whatever you do, you can note it down in a project logbook. So now in this COVID pandemic situation, since many of you may have online classes, you can think about sharing editable workbook, Word file where each of you can edit whatever share of work you have done. This is going to help you at the end only. Like when you are preparing the project report, you can make use of this logbook to find out the path you have traveled to accomplish that project. Then once you have done all these things, then literature survey is a critical thing. Literature survey is meant by, you have identified a title, your guide has approved that, you need a background study, because many of the people may have done some work related to your area. You can find out those things, find out what others have done in the corresponding area. You can do a basic research, find out the innovations, find out the updated data regarding that title. Let me show you how you can do a literature survey. I have taken only two. The first one is an IEEE Explore, and the second one is Shodh Ganga. Let me show you that one. I am now in the home page of IEEE Explore. So you can see the URL mentioned here. It is IEEE Explore. So in fact, I have done a search that's why it is mentioned as VLSI testing. So otherwise, if you are logging into IEEE Explore, this is the home page that you see. You can look into the URL, see that it is not IEEE. If you are doing a Google search, do use the keywords IEEE Explore so that you are correctly directed to this page. Many of your colleges will have a IEEE membership. I'm sure about that. You can use the institutional sign-in to download a paper. Without an institutional sign-in also, you can get the title of the papers. So I can type the keywords according to my project. These key, when you are giving the keywords, a lot of data regarding to that corresponding area will be returned to you. You can see that there are a lot of data. So the keywords that I have typed is highlighted. You can sort it according to the relevance, newest, oldest, those things. A number of data will be there. So as I said, if your institution will be having the membership, you will be able to download that. You have a filter over here. You can take conference, journal, magazines, early access articles, etc. also. This is one method. The second method, let me take you to Shodh Ganga. This is what we recommend nowadays in our university. It's a collection of Indian electronic theses and dissertations. Whatever project reports and theses is submitted to the colleges or universities across India, you can get a wide variety of reports here. You can see the statistics here, the number of full text theses, synopsis, university contributing, the university signed MOU. So this is what we promote now. So being Indians, we need to look into this and see what others have done in our country. Okay. So let me go back to the slide. Then after doing a literature survey, as I have shown you that IEEE Explore or a student report from Shodh Ganga, you will get a pretty good idea about the current uh, position of your area of interest. Say for VLSI testing, I'm from VLSI testing. So what is the current trend? We will get to know that. Once you do a pretty good enough literature survey, you can plan. So planning is a very critical part, and also I would recommend meeting up your guide once in a week so that they will give you a pretty good idea about the way to proceed, the time plan required, etc. Also, proceeding further, implement the plan, then you need to test it also. Then there will be milestone presentations. So all the universities have milestone presentations or review presentations. T number will be there for all the universities. A minimum of 3 will be there. So the first one being a review for literature survey that you have done. Then second one will be to evaluate what you have done after the literature survey. And the final one to see what you have further done regarding the project. Then these all reviews are done so that to observe, evaluate, like Dr. Krishnakumar has said, to give you the feedback. So you have to take the feedbacks in a good way that is going to help you the project. Then finally complete the project, completing the document, final presentations and the submissions. So we may not be, due to time constraints, we are not able to tell further regarding the documents, final presentation, submissions, etc. But we will have a good look into that.
Okay, friends, next I will introduce a tool for planning and documenting or designing your basically planning your academic projects. It's called mind map. This is basically for brainstorming. So it is a mind map is an easy way to brainstorm thoughts without worrying about order and structure. The very freestyle tools. I think this tool is used from very old era. So it allows you to visually structure your ideas to help with analysis and recall. So a mind map is a diagram representing tasks, words, concepts for items linked to and arranged around the central concepts of concepts. What is your central concept is our project. So using a non-linear graphical layout that allows the user to build an intuitive framework around the central concept. So mind map can be used as a simplified content management system. It allows you to store all your data in a centralized location to stay organized. So you can, in the project logbook also you can, so better to draw a mind map in your project logbook. So Mrs. Geethu explained, Professor Geethu explained that project you have to keep a project logbook. So so this mind map can be drawn in your project logbook. So I will show an example. See, this is the basic structure of a mind map. So here there is a central thing. This, see, the mind map can be drawn in a paper using pen, sketch pen, or whatever you want, using even a pencil or whatever you want, or you can draw in a software. There are many free softwares available for drawing a mind map. Whatever you like, you can do it. In the computer also you can draw, in paper also you can draw. So if you are taking a paper or in a computer, in the center area of the screen or paper, you draw a shape. This shape may be anything. This is the rectangular shape. You can draw a star, you can draw a circle, whatever you want. So I told this is a very free style thing. So whatever you want, you can do. So it is very convenient. So you draw a center, anyway, you draw a central figure, central shape. This is a rectangular shape, and write your project title here and expand it, connect it, and write your idea here. Idea 1, idea 2, idea 3, then sub idea, like this will grow. So this may not be done before starting a project. You can add in between the project also. So anytime you can add, delete any column, any column or figure shape in this one. So next I will show you some mind map available. I took it from net only. So this is a project. This project, they wrote like they are using a rectangular shape. Idea is their project name is remodel the kitchen. How we will remodel the kitchen? So there are many tasks in remodeling a kitchen. Their ideas, they are written here. So what they are doing? They are given many colors. So what will do in the remodeling kitchen? They are planning for kitchen cabinet. They want to paint it. They want to then some activity like they are choosing the type of cabinet, installing the cabinet, and all these things like the wood floor. They are trying to install a wood floor in the kitchen. And old one, they will take down old wall and put up a new wall, etc. So either they also want to paint the kitchen, so purchase new appliances like microwave oven, all these things, activities and events, and even the item name they included in the mind map. So you can start a mind map like this for your project. So one more thing, one more example is a this is like they are using some other shape for this one, not a rectangular shape, the diamond shape. So here project is there. So they are writing the project constraints. So this is not an academic project. So project constraints like dependencies for the project. So internal controls for a company project, regulatory bodies are there like government bodies, like inspectors, different types of inspectors. KSCB project, you have different types of regulatory bodies like factories and boilers regulators, electrical inspectorate, and other things like environmental protection committees are there. There are many things in executing a project. So different approvals are needed. Like suppose I am involved in a project called the Palliwas selection scheme. The Palliwas selection scheme require a lot of approvals from environmental approval is required. See, you can know the hydroelectric project, how many approvals are needed. From forest, we require approvals. From mines departments, we need approval. From factories and boilers, we need approvals. Government, we require approval. We from India government, Kerala government, all governments and other local bodies, we need approval. But these are not needed for a student project. Anyway, some constraints you can map here. Scope you can write here. Here they are using a different shape. See, this shape you can define your own shapes and you can write it. So it's very convenient. This may not be written in 1 day or 1 hour or in a 1 week. This may be written in 2 or 3 weeks, months, or during the entire project. So this is a project mind map. This is also an industrial project. So project this deadline and timetable you can also use, because resource availability you can use where lab machine is available, etc. This customers, prices, sales, marketing, reviews, etc. are not needed for your project anyway. So this is an industrial project. So this is also a type of mind map. So a project can be hardware, like we are using a tangible components like electronics component, motor, electrical components, motor, and simulation based and purely on a computer. We are using computation technique. We are using some we are copying or modeling in a computer, that is called a simulation project, and also purely a software project like a software control or a user interface, etc., or can be a research oriented. See, very few BTech projects are coming under the category of research oriented, but there are some research oriented projects like research oriented. Research is a research, that's searching again and again for the truth. So you can do it like you can study on a particular thing, you can write the pros and cons, and again you can go and study the backgrounds, etc. It's a research oriented project. That's also, I don't know, some colleges are not approving it, some colleges are approving it, that depending on your institution.
So project, what are the, we have learned about project, so what are the things that evaluators look for? Like I said earlier, when you are doing a project, you may have to go through several milestone reviews. Milestone reviews, you will be evaluated, a panel will be there who will be evaluating your progress, giving you some feedbacks. So what exactly are they looking for? So the first thing they look for is the basic knowledge. So in the first, those things will be done in the first reviews, literature survey. Do you have enough background knowledge to carry out the work that you have defined? Are you defined that work properly? Did you define the tool? Uh, or basically basic knowledge and the background study. Then the quality of the work done between the consecutive reviews. What is that quantity of work? Is it a qualitative one, etc.? Then last but not the least, the presentation and the contribution from individual members. So usually when we take projects, a team is there. There are some students who are not at all contributing, and there are some students who will be doing 80 or 90% of the work. So those things can be pretty well evaluated by the panel, because you have a expert panel in your university, very much expertise in the job that they do, and they will be readily able to tell whoever is contributing much into the project. So those things will also be evaluated when you are doing a milestone presentation.
So next is innovation. See, all projects have our projects are not involved with innovations, but some projects are involved with innovations. So what is innovation? Innovation can be defined as a new idea, creative thoughts, or new imaginations. See, innovation is different from invention. Not all innovations require an invention. For example, see, have you came across cycle pump? Most of you came across cycle pump, no? New model cycle pump. What is the difference between old model? In my school days, we have cycle pump. It is very, very difficult to use because we are using piston to push the air. But some researchers or some maybe a local man or some somebody, what they did an innovation in the cycle pump. Just they inverted the moving part and the static part. That is, the piston become the static part, and the moving part become the chamber of the piston. Then what happened? So it is very easy to pump because they are using the volumetric efficiency. So these type of innovations are there. This cannot be called as an invention as such, but it's an innovation. See, think of mosquito bat. Every day we are using. What is the idea behind it? It is a stepped up voltage. Stepped up voltage they are using for killing mosquitoes. When this type of innovations, we feel it is very simple, but it created a lot of social and market impact. So these type of innovations, small idea can change the lives of million and can create an impact on society or can impact on a market. So you can patent it, as Gomati madam told, you can patent it, you can start a company. So patenting process very easy now. You can approach a council or you can do it yourself. So you can patent the idea if it is an, so innovations, so inventions are patented, not innovations. So innovations can be explained as a practical implementation of an invention. So there are many innovations. So you have heard of Henry Ford? Henry Ford is the chair. He was the chairman of Ford company. He is the founder of the Ford company. What was his innovations? See, his innovation was an assembly line in car manufacturing. That assembly line means each staff is doing a particular job for, like a particular X person X is fitting the tire, he will continue fitting that tire. A particular person is fitting the car windshield of a car, he will continue in that job. So the line will move towards front and all people is assembled to do a particular job. This will increase the efficiency of people and productivity is increased. Then what happened, you know? This car was an is a very costly item in that day, but middle level people in US came to purchase, or they become they are eligible, or they have ability to accommodate or purchase a car. So he created a big social impact with his innovation. So there are different types of stories in innovation, small innovations you can see in your society. So you can try to understand these innovations. So what are the different need for an innovation? We have only three things for innovation. What I am telling is you try to incorporate an innovation in your BTech project. These innovations will add value for your projects. This will bring you more marks. This will help you to find more marks. This will increase your confidence. This will increase your self-confidence, and also your presentation will be more appreciated. Your idea will be more appreciated. Sometimes you are going to become a big, a big business person. So innovations need only three things. One is the recognized need. You heard that needy? It's the recognized need. Competent people with relevant technology. See, your group members may be competent for doing all these works. You are selecting people like that, or you bring that people, your group members, to that level. See, suppose there are 4 members, 3 members are very academically brilliant, and one student is not that much academically. Maybe he are different other skills and knowledge. So use his skills and knowledge and bring him up to that what you are telling to that level, and help him also. It's a society, so you have to give a helping hand for him also, not do not ignore him. Bring that person also and work as a team. So you also need a financial support for maybe BTech. You need a financial support. If you are doing a big work, you need a financial support. You can take it from your college if college is willing to do. There are a lot of things. Government is doing a lot of support for new business and startups. So you can try in that way also. So one more element I told is research. Research, as told, is research, searching again and again. So this research is we sometimes some students are thinking research is a area where we cannot do anything. Is a very high class people are doing research and they have their own domain and other thing. Not like that. Research comprises of creative and systematic work undertaken to increase stock of knowledge. Research is very simple. See, anybody can do research, not an academic person. Anybody in this world can do research. Research is very simple. So it is like a following to find a truth, following a particular event again, and just to follow that event, collect data, and again you study it, and again collect data and study well and map it, and other thing you can find some inference. It is a research. So including knowledge of humans. See, it is used to establish or confirm facts, etc. So research is anybody, you can also bring research in your BTech project. This is nothing big thing. You can do some work in your BTech project. It will do research, and you can also incorporate that part. Also, you document it, and you can tell that in our suppose we are giving 10 volt, it is giving output as 5. Suppose we are giving 15 volt, it is giving output as 7.5 volt. That type of things you can do in your BTech project, and also you can tabulate, draw the graph and other things. So it's a small research. So if you are, what happens if you are giving 0 volt? What happens if you are doing 100 volt? So this type of inference also you can write, or you can simulate it. This is a small research. So research consists of 3 steps. One is pose a question. So what happens if you are doing this one? What happens if you are doing this thing? Collect data and answer to the question, and present the answer to the question. It's very simple. Research consists only 3 steps: pose a question, collect data, and present an answer. So next is prototyping.
So should we take a break for the question answer session? Hello.
We can have a break. If the questions are there, students can use the chat box, or else let's take a break for 10 minutes.
Mute.
We'll welcome back. We'll start again. It's a prototype. See, prototype is a working model actually. It's very, very important in industry. May not be much important in your project. Maybe your project final result can be considered, or final output can be considered as a prototype. The prototype is a working model, may not require all features, may not be as efficient as the final product. So this is prototype. Maybe not as or this may not be as same dimension as the final product also. So I will tell an example of prototype. See, whatever God see, you can see a lot of prototypes in nature itself. You can see a lot of prototypes in nature also. You can see you can consider the cat as a prototype of the big cat, that is a tiger or a leopard or other things, no? So maybe you can consider God first created the cat and tried it how it's working, and then you created the bigger one. Like everything, I think most of the thing in nature has got a prototype. So after making a small prototype, you can study what is happening, what is the problem with it, what is the see what happened when they prepared cat as a prototype. Cat has got enormous compared to its body weight. It can jump up to very large distance compared to its body weight and its size. But if we are making a tiger with the same, or we are scaling a cat to a tiger, what happens? It will be a very, very dangerous animal. So its hunting power is reduced. So like that prototype, we can increase the functionality, or we can take away or decrease the functionality of a prototype. There are you can see a lot of examples like jackfruit. What are the things? Lot of things you can take from nature. Lot of prototyping, small things and bigger things in nature. So we can consider the small thing as the prototype of the bigger one. So, or vice versa. A prototype is an early sample model or release of a product built to test concept or process, or to act as thing to be replicated or learned from. So this is very, very important for the students who are trying to start a company or trying to market your BTech project. So you know that many of these world's largest company, including Microsoft, Google, Facebook, etc., are by the students of education institutions. So the prototyping model is usually in company they are using to check the or test the user's requirement or study the user's requirement on reduce the risk and uncertainty. So when you are, see, I told the example of the risk if you are scaling a cat to a tiger. So the hunting power will be increased. So a tiger can jump to a very large distance, that is very danger to the nature. So different types of prototypes are there. One is throwaway prototype, second one is evolutionary prototype, and third one is incremental type prototype. These are there are many classifications. This is a simple classification. Throwaway prototype is will make the prototype, will show it to the user or whatever you want, customer, then we'll take the feedback and we will ignore the prototype. So this prototype, somebody will ask a question that why prototype we are throwing away prototype. See, making a prototype itself is costly. In our company, we have to make a prototype for a generation plant, a generator. So we made it in Sweden. So India, we have no facility to make the prototype. So the prototype itself cost around 9 crores rupees. It's a throwaway prototype. It is a small type of prototype. It is tested in Sweden. In Sweden, it is made in Sweden and tested in Sweden. Why? Because the original thing may require 100 crores, and we are making it, then we are testing it. If it is not performing well, we have to will use this 100 crores. Now we lost only 9 crores. So we made a prototype. We tested all the parameters, simulated the remaining parameters, and given clearance to make the original generator and turbine. So this happened 2 years back. Anyway, next is evolutionary prototype. See, some modifications based on original prototype. Suppose that prototype is they will keep this prototype, and if a second customer is coming and will tell that they want more efficiency or more weight or some other features, from that we can make it and we can show the customers. And third one is incremental type prototype. Here we are planning all the functions, and after making each functions, we will show the customer and get his approval. And finally, this incremental prototype become the final product also. This will not be thrown away. This become final product. So this is a very simple flow model, process model of a prototype. We'll make a prototype, build a prototype. User satisfaction is there. If it is not, user is not satisfied, we'll take a feedback, and again we will do prototype or change the prototype, and finally we get a user satisfaction. Here we can consider user, maybe your colleagues or your guide. So what are the benefits of prototyping? Learning by doing is the principle of prototype. So improved communication from user and also from mentor, you can get a feedback and you can do it. You can use a incremental type prototype. I suggest for a incremental type prototype for beta. So that will be your final product and do not throw away it. So improved user involvement. So your guide you can show in between your guide that this is the product you are going to build. If it is a product or it's a software, you show him or her that this is the thing we are going to do. So she will suggest, or your colleagues will suggest some or some functionality, so you can incorporate it. So see, many of the product what happen in industry is the requirements are not clear. Neither the user, neither the customer or the stakeholder is clear about the requirements. So what happens? Once we make a prototype, we'll make a software or show them, then they will suggest that if the color is if you have to change the color, you have to change the size of the button if it is software. If it is a product, they will tell that you want to add this functionality, you want to reduce this functionality, this is not needed, this should not like this, etc., etc. Then only the user or customer will understand many things about the product. From the company side, we also will understand then only. So what happens? We can prototype will help us to finalize the agreement between the customer and the contractor or the company. So after showing the design, we can freeze the design and we can make the original thing and we can deliver the product. So this is the prototyping sequence. This can be used for your BTech project. This BTech project, your final thing is maybe a prototype. So anyway, I think it's very difficult to make a product with a BTech project with a limited time and resource. You cannot make a product. You can make only a prototype or a proof of concept. So it is called one more thing is that a proof of concept. So you can make a prototype and you can show it to the public and you can patent it. Then you can make a product. Making a product is different from a prototype. So different sequencing prototype is requirements gathering. You have to collect requirements. Quick designs. Design will be not like a product. Maybe the prototype may not have the entire functionality of the final product. Maybe some functionality, maybe important functionality will be incorporated in the prototype. Minute feature will not be incorporated in the prototype. Entire casing and entire stand and other type of things for a product may not be included in the prototype. But main functionality will be included in the prototype, and there are many types of software available and many companies are there for they are doing the prototyping. Quick prototyping types of company you can get in. They will do a prototype. You tell them, they will make the prototype and give you. So make the prototype, then customer evaluation, you can show it to the user. Refinement, their suggestion will be incorporated. Then design will be looked back and they will give to the design team about these things and will change the design if they want. Then finally the word is product engineering. This product engineering may not be in your BTech project, may not be, you may not come with a product after BTech project. Maybe there are, but you can start the first basics of product engineering during BTech.
So let me talk a few words about the report preparation. So this report preparation, in an academic background, you will have to do a proper documentation of whatever work that you have done. Many of the universities now opt for the first option, which is written here. It is LaTeX, and the second option is a Word format. Now, why do we require a report preparation? Is it clearly shows the journey that you have done for completing the project. So, like I said earlier, you may try with a few methods before getting a successful result. All these things can be included in your student report. So a proper documentation is required to show the journey that you have traveled. So these two are the options for report preparation. Let me show you these two examples. So this is website for LaTeX. This is downloadable. You can download the LaTeX software. You can use that. So when you want to publish your work, because nowadays everyone publishing the work that they have done. So many of the conferences or journals, they do offer a template, a LaTeX template. If you need to invest a few initial hours for learning this LaTeX. Once you know only the basics, I don't want to say that you should be an expert at that. No, only a basic understanding will help you a lot. This LaTeX template, you can download it. You just need to provide the inputs in that LaTeX template and you can generate the PDF. There is one more option in LaTeX. It is a sharelatex.com. So it is online where you have to register, then log in to get the provide the data and get. So you need to provide only the data. The data, I mean text, the table, everything. Then you will be able to generate the PDF. Or the conventional method like word processor. So Microsoft Word template is also there. You can use that template to prepare a report. So many of the universities will have templates. So you need to stick on to the guideline provided by your university. So the report format, I would also like to show some samples from Shodh Ganga. So the Shodh Ganga, they have this is the website. I have taken an example also. This is an example report, guidelines for BTech project report preparation. This is specifically by the Mechanical Engineering Department of IIT Guwahati. Then this is a report. The first one I have showed is a guidelines, where the second one, this one, it is a project report. Whatever is submitted to the department, it is uploaded in Shodh Ganga. This is by IIT Delhi Department of Engineering Physics. So it's a report prepared by a student and uploaded by the IIT to the website. You can see I will just have a I'll just take a few pages only. Introduction. So they have prepared the report and it is uploaded in the website. So the difference I have previously mentioned about the literature survey. So there is a small difference in the literature survey if you are looking into a paper, specific paper from IEEE Explore and sample reports from the Shodh Ganga. Sample reports, if you are taking these sample reports, it will have uh, it's easy to understand. I would say that it's easy to understand when you are doing a BTech project. Take a report of the concerned area, take a look into that. You will get to know the journey that they have traveled for completing that project. But when you are looking into IEEE Explore, these are published work. It's kind of step above that one. So you have an abstract form. It's like a capsule form of whatever work that they have done. Study on the cost of on-site VLSI testing. So it's going to tell about that specific topic or that specific area work related to only that work. But if you are very new to projects and all, it's very good to take a sample report, project report from the Shodh Ganga and take a look into that. You will get a better idea. Now regarding the best practices.
I will share some best practices for academic projects. So you can follow this one to get a better project. So there is a saying by Henry Royce. You may not heard about Henry Royce, but have you heard of Rolls-Royce car? No, the founder of Rolls-Royce car, one of the founders of Rolls-Royce car, told small things make perfection, but perfection is no small things. This is applicable to your beta project. So you need not go for big project, but you have to select a or make a complete project. Not it will if you are intended for 5 functionality for your project, the whole 5 functionality should work. This that then your project will be a complete thing. So small things make perfection, but perfection is no small. Make a perfect BTech project. So another idea is keep it simple. No, do not make it complicated. Idea and the product should be simple. One more thing, think that you are creating the product for another person and he should operate your. See, when I was in academia, I saw many projects. What happened to the project, including my BTech project, this project or product require my team members presence to run it. A third person cannot operate it. So we require our own laptop, we require our own system, we require our own framework to run the project or the product. So I always suggest you think of a third person. You are not available in the situation. You and your team members are not available in the situation. Uh, then also a third person can run your project. So then it will become a good prototype. So there is a scope of the further development. This project, all project, and also testing. Testing is very important thing. So what will happen? We'll try to finish the project in the last few 11th hour, and we will not do the testing. And during the final presentation, we are trying to test it. It will collapse, and we will be disappointed. To avoid this, you finish it. Select a small PTech project, do it, test it well, and even you should be confident to hand it over to a third person so that he can even run the project. So another case, select a problem which can contribute to you knowledge and skill for future career. See, suppose there are many students who got placements. Suppose you got a placement in a company and the company is working on Java. It's better to take a project in Java. Suppose a company is working on design, better to do a design type of project. Consider all the issues that can happen during the rollout. One more thing you have to think of your project is during rollout, during the final course of this or rolling out of this prototype, there will be many problems. You have to consider all these problems, and if you are considering all these problems well beforehand, your product will be a very good repeated project. So start as early told, document well. Start documentation. Document well in such a way that others can understand and operate your product, if any, without your help. It's like a operation manual. When you are purchasing a gadget, you will get an operating manual. That operating manual should be complete in all sense, so you can operate it. Like that, make an operating manual with your BTech project. It will be a good practice. So see, there are one more thing. This I am basically from electrical field, and my and Geethu is from electronics field. One I observed is these real world problems have no field. God has not given any difference in problems. So what happens during my experience, I am an electrical engineer, but I used to supervise civil work. I used to supervise mechanical work. I used to even work as a supervise as a chemical engineering, because all our material is equipment part require support from all this engineering field. There is no difference. See, we have in our powerhouse, we have mechanical things are there. They require mechanical understanding. Like we have turbine, like turbines are there. These Pelton wheels are there. Francis turbines are there. Hydraulic valves are there. Then pneumatic operated things are there. Then we have electrical things like a generator. Then we have electronics things like electronics control systems are there. Lot of relays are there. Then we have computer controlled SCADAs are there. See, we as an engineer, we have to attend all these things. Then civil is very important factor in a powerhouse. We want civil things using during my experience in my 245 kV GIS switchyard, the first 245 kV level gas insulator switchgear switchyard. What happened is I initially used to supervise civil works, because we require coordination with the civil engineers for embedments and our erection of our equipments. Then, during my experience in Palliva selection scheme, Chengulam Paros also, Pambos also, I supervised a lot of civil works also, mechanical also. See, I went for inspection of mechanical turbines. I checked how flow meter is working. See, so please understand that there is no much difference between branches in real world situation. You must understand all engineering. So there was a question from an electrical engineering student whether he or she want to opt for a core electrical project. See, no need. Nowadays, there is no core electrical field. Electrical field require support from electronics, support from computer science, programming also. The relays we are using in my in my office is mostly now software programmed, but it is controlling electrical power systems. So interdisciplinary projects are always welcome. So you cannot go with your own field. You can, but the complication is increasing, and you may opt for interdisciplinary project for better understanding of the other field also. So there is no need that you have to concentrate on core electrical engineering. Moreover, core electrical engineering projects are not so easy to develop with small money. You require a lot of money to develop a actual core electrical product. Moreover, the the electrical project as you developed are working in very small voltage may not be scalable to extra high tension or high voltage. So that is a very different. So your product will be away very far from industrial standard. That also you have to keep in mind.
Can I interrupt?
Okay.
So for that specific question, I would like to say a few words. It's like if you want to focus on core, the question by Abhirami, if you want to focus on the core engineering stream that you have taken, because some universities may not allow you to take interdisciplinary projects. So some universities do offer, but some there which still doesn't offer there. But in that cases, you can think with your situation and you can formulate your own project. I would like to quote a small example. I have a student who is coming from a village in Andhra. He is from a farming community. His father is a farmer. They have a problem like some animals were roaming around in their field, and they have to take shift to sit and watch the crops during the night. So he is the first one coming for a engineering course, and he wanted to do something for his community. It was his initiative to develop a project, develop and actually it is implemented there, which is based on embedded systems, which will create an alarm with a sound and light whenever animals are intruding in this field, in the crops during night time. So it is actually implemented there and it is working fine, and they are able to take good sleep. These farmers are able to take a good sleep. So it is very happy to see that our students are coming up with these projects. So with your limit, you can think about creating a project like this also. So you have to go to your university, see if they do allow interdisciplinary. So like I said, some may not allow. That's one of the issues.
Okay, so we'll continue. Select a problem which can contribute to you knowledge and skills for future career. I explained thing. So all the best practices have explained. Then we'll go for next session. Is a social impacts. So this is very important. We feel that our students require more view to our society, as well said by our VK Damodaran sir. So the social impacts in project is a very important thing. Whatever you are a part of society, you are coming from a society, what you want, you have to give your knowledge, your skills to the society. So keep in mind a word that sustainable development, not for your BTech, also for your future career. Sustainable development is a confluence of social, cultural, economic, and environmental. These all factors, 1, 2, 3, 4 factors should be kept in mind while you design a project or a product in your career or in BTech. So this is very important. I am not going into details of sustainable development. Please keep in mind, you have a view of your environment, your social view, cultural view, and also the economic of the project. So some project like social impacts can create social impacts like water management. You can think of some projects in water management, assess supply adequacy, modeling different supply and technology alternatives of water management. May not be directly linked with electrical engineering, but you can. You can have some link with electrical engineering in water management, switching on the motor and switching of the depending on the pressure, you can operate a pump and other mechanism. Geographic information systems for identifying water availability, storage, transmission, and distribution of water, that also can connect in some way with our engineering field, quality monitoring and that type of things. And electricity shortage, any method for reducing the electricity shortage by decentralized centralized generations like solar, then wind energy and other type of tidal, etc. You can think and experiment as your BTech project. It should be, you can make a load balancer or that type of things. Then economic growth and employment, think of a project that can suit for economic growth and employment. Then empowerment.
I would like to add upon this empowerment. So, like Dr. Krishnakumar has said, there is no branch-wise division. So, it is for our convenience only. We have these different branches: computer science, electrical, electronics, civil. Like real world doesn't have a categorized problem, an electrical problem. You can think the scenario of going to a hospital. You have specialized doctors there, no? To you may have encountered those situations. So similarly, a real world problem doesn't have a branch wise we need to have a harmony between all these different branches. So for our convenience only, we have categorized it into different branches. Now, regarding this empowerment, it is increasing connections between citizens and the citizens to institution. There are a few points mentioned here. What I want to mention is you can also think about the empowerment that you can bring for old aged people. Specifically, for an example, I would like to take a mobile example of a mobile. Mobile is actually designed in VLSI. Uh, what we design is for maybe 1 or 2 years of usage, but that also is done by keeping in mind about the people who are actually going to use these gadgets. So mobiles are designed for age from maybe 10 years. So nowadays it's like 5 years. So that 5 years to maybe 50 years. So beyond that, you know the situation. All of you have old age people in your home, how difficult it is for them to learn these things and understand and to operate. You can think about designing products specifically for old age people or for kids. So I would like to emphasize for old age people because they have very difficulty in designing to understand and operate these gadgets. So if any automobile engineers are attending, you can think about the changes that you can do in a product which will suit the old age people. uh, that is meant by empowerment. Then transportation, you can think about. So regardless, these examples are regardless of the branches. Don't think that you are from a EC background or a computer science background. Everybody can contribute for a problem. No one is standing alone. Everybody can contribute. Online reservations. So specifically in this pandemic, there are a lot of problems faced by common people. So with people who have a middle class and above, they may not have so much problem, but there are people who are suffering so much. You can think about the changes that you can do from your own level. Okay, safety, fuel monitoring, consumption, assets, facility. There are several areas. You just need to open your eyes and see the real world problem. So as engineers, what we want all of you is to open your eyes and see the real world problem that common man is facing.
So we'll continue with different types of problems, different areas of problem like food and agriculture. We just noted some problems only. So we can do something for production of food and supporting agriculture based on. I have a student when I was in academia. That student she designed a system that will sense the moisture. Is a long back, maybe 15 years back. She designed a system. It will measure the humidity and will automatically water her garden. So she implemented in her house, and the type like we have our own like that time itself we designed some a project called e-Shikshak from students only. It's a e-learning platform with all facilities like WebEx. That is, but it is they couldn't scale it. They dropped it. They done it well, very well. It's a good prototype, but they couldn't scale it because they got different jobs and they went away. So that I will discuss. Then healthcare, which is very important during these days. Telemedicine. So electronics students, computer students can help, and also our electrical students can make a lot of things like artificial breathing apparatus and other things that can help to support the pandemic patients. Bioterrorism, epidemics, etc., hydrological sensors, satellite, etc. I'm just noting down some areas that you can focus.
Only a few suggestions. You can always
you can always widen up. This is e-waste. So how can e-waste what you can do for what of e-wastes are produced, what you can do for it. So towards a greener technology. So you can think of your product as a greener green initiative. Your product you can label it as a green initiative product. So what we can do, develop a sustainable green computing or plan or your project, recycle, reduce paper consumption, conserve energy. That type of project, we electrical engineering students can concentrate on energy conservation. Always.
In fact, there is a electrical engineering group of students who has started with a company who is they are modifying the waste. It's like they I don't remember the company name. It's by the founder is Niveda. She has a company which modifies this waste to a board which can be used for building constructions, those things, modifications, those things. So it's not like these can be done by only a specific branch of students. Everybody can contribute.
So some broader area, specific target to electrical engineering students, you can work on smart grid. Smart grid is a very hot topic. Smart grid, as you know, is a power system is linked with the communication, bi-directional communication system, and advanced transformer like solid state transformers. There are some work happening on NIT Calicut and energy efficient transformers. So there are a lot of scope in non-conducting instrumentation transformers like CT, PT, and other type of things. We can make it as non-contact because the contact type CT, PTs are very costly. Then fault localization is very important. In HT, what happens? You are getting a lot of outage in your home. This can be reduced. Now there are in our company we are using only manual techniques for finding the localizing the fault. So you can think of it for an automatic system. Then data collection of your electricity usage and other thing, metering, smart metering. There are implemented things in smart metering. Maybe you can add some value addition. Real-time transmission and distribution status data. These are many things are available, but I will not tell you to reinvent the wheel, but you can add something to it. Spin SCADA system, loss reduction and transmission and distribution efficiency, smart control for distributed resources and microgrids. Nowadays, microgrids are gaining popularity with increased proliferation of solar PV cells. Analysis of our network vulnerability, network issues and interdependencies during and after extreme events like storms, flood, earthquakes. We have faced last 2 years. We faced a lot of collapse in our network with during flood time. The scheduling generation in a smart way, you can think of it. in integration of non-conventional energy in a better way, you can think of it. E-mobility. E-mobility is one of the hottest topic in electrical engineering. So you can do some work on e-mobility, so with the photovoltaic cell and other things like e-mobility, not only in road, you can think of in boat and other things. So load control, load shedding, and load management. There are a lot of things. Presently, we have even implemented our most sophisticated automatic demand side management system in our company. It's like you can when they are switched off or selected power line HT lines can be switched off from load dispatch center itself. The work is going on. It will be implemented in few weeks.
So broad areas regarding the EC background would be mechatronics, VLSI design, VLSI testing, then signal processing, and also in VLSI signal processing, then image processing, then social impacts. So what you can do within your academic framework, you can recall the face of the, as Mahatma Gandhi has said, recall the face of the poorest and the weakest man whom you may have seen, and ask yourself if the step you contemplate is going to be of any use to him. Will he gain anything by it? Will it restore him to a control over his own life and destiny? In other words, will it lead to Swaraj for the hungry and spiritually starving millions? So, we together we can make a lot of change. You can, budding engineers, you can think about the possibilities from, even if it is a very small step in the form of a BTech project, you can think about these things. Then you be true to yourself, because if you are not naturally interested in doing a BTech project, there won't be a grace for the work that you do. Only you know that you have put your 100% heart for the work that you do. So with that, before going to the next slide, I would like to show a few videos regarding the changes. Yeah, it is just for your thought process only, just for input for your thought process. Let me show you some slide, a video. This is for specifically designed for the COVID situation. Some robots which can be used for the present scenario.
Annapurna is a tele-operated robot developed at Humanitarian Technology Labs, Department of Electronics and Communication Engineering at Amrita Vishwavidyapitham. This robot can be remotely operated by the operator or the nurse to serve food, drinks and medicine to the patients in the isolation wards. This way, the nurse or the operator need not come in direct contact with the patients in the isolation wards. This robot can be built and assembled within few weeks, and it comes at a very cheaper rate of less than 25,000 rupees.
Let me show you one video also.
It is a tele-operated wheelchair for transporting the patients from isolation wards to test labs or for X-ray without the need for the operator to touch the wheelchair or touch the patients. It works in a Bluetooth wireless interface, and the operator can operate it at a safe distance of more than 1 meter. In this way, there is no need for the operator to come into direct contact with the patients or the wheelchair.
So that is only a few examples. So we'll go to the next slide, problems with students' projects. What we have seen in our experience, it is few points only.
In our experience, these are students' projects and develop and throw away. So after getting or completing the BTech project, nobody is caring about their project. Even myself, I discarded my project after BTech. I couldn't do anything on that project. So presently the BTech projects are develop and throw away. So we are doing a project for a project, not for a project for a course or project for a society or project for an engineering solution, just a project. So this should be changed. Then, so we are creating problems for project, not project for a problem. This also should be changed. So we have one more thing, no proper requirements, analysis, design and testing. Just we go and start implementing project. So what, so we'll get a product or project that very inferior in quality. If we are following all these steps, we'll get a better project. So what happens? There was a project. It's an experiment with I think University of California, and when I was working in the institute, with that institute in my department, so we gave a software project, same project for the students in India and also foreign students in California. What happened? So we gave 4 months time. But the first, what happened, after 2 weeks, our students started implementing the project. The students from university, first 2 months they are properly studied and designed the project, and they took only 1 month for coding and we took 2 months for coding. And what happened during testing, our project failed miserably, and well planned and designed project by the foreign students worked well. This is a very good example of implementing, not comparing with India and other nation. That is different thing. Is only an difference in approach. Only difference in approach. What I try to say is you have to implement a good time in planning and design phase of your for students project. Then only you will get a better output. So students are not following proper coding standards, and we are one more thing what I feel is industry products require to follow some regulations. A lot of rules are there, some standards like Bureau of Indian Standards, Indian Standard in ISI. You heard of ISI and BIS, World IEEC standards. This all industrial product required to follow all these standards. Our students project, we are not aware of any legislation. See, there are legislations in each and every product. We have to follow the legislation. We have to follow industrial standards. There are standards for even for a cover you are using for a product, there is standard. Even for the water tightness you are using for a product, there is a standard. Better you go, if you are making a prototype, if your output is a prototype, you have to see you are following the industrial standards and legislation. You can very proudly say before the evaluators that we followed IEC 90, or we followed this standard for reducing the ingress of water to our product, and it can be used in even in rain. So these type of standards and are used, should be used for the project. Then testing is very important. Testing like alpha testing inside your inside your team, you have to test it. Outside also you have to go, like your friends also should test the whatever the item you are doing. So no real implementation. Most of the things students will fail in real implementation, and now no continuity of product. Once we did, I early told students will throw away their project, but we want to introduce junior students and to continue with the project. No completeness project. most of the project I evaluated during my academia is complete up to 88% only, not more than that. They will tell that our project is complete, but we know that it's not complete, but it's a BTech project and students did their part very well, so we will give mark. That is different. So this project, there is no way to store. Most of the academic institution, there is no way to showcase these projects. There should be some place to store and showcase this project. Then only juniors can continue the development.
It's always innovations are possible, whatever. Even if you are developing something, the juniors can take up that one, do the modifications also, because every fine tuning can be done for whatever work that you have done. You can also, even if you have passed out from your university, you can also contribute, you can also be a part of your college work that is going on, that is going to strengthen the alumni, or those kind of stuff are also there.
So a few suggestions. These are our own words. So may not be maybe or may not be relevant. So students' projects should be developed and used, and we have to develop a project for society and not for a project for project. Projects with life in all sense. I am telling that should live. Your project should live. Project to solve real world problems. Continuity should be ensured by ensuring inducting certain junior students to your project or discussing with them so they can continue the project and to become a good project. Complete and implementable project. You want common repositories in colleges. See, you should be, things should be open. If your technology, I will not tell. If you want to patent it, do it. Do not disclose it. Identify and solve challenges in the file to field. It's different. In the lab you can work many things, it will work, but in the actual field, very difficult. See, recently I came with a project for a conductor that is snapping. Still I am working on it. It's working very fine in all lab situation, but we are trying to test in field. It will require a 1 year testing in field to ensure that it will work fine in field. So technology transfer, try to transfer the technology for the if you develop the technology, do technology transfer for money or for a good cause. Easy to use type of product required. Should be adaptable, scalable, and sustainable project is required. So a few references. One more thing, I got a suggestion that I should explain how a project is happening in my company. I am telling about a large scale project. So recently I was involved in a very large scale project. It's some total cost of 60 crore rupees. So what is happening in the project is, so it was at this is the project is continuing. It is a turnkey project. What is happening is the entire contract is for engineering, designing, and supply and completing the project. So what is happening that they will do a field survey initially. They will plan for civil work. Then parallelly they will start manufacturing. They will initially based on all standards, and will make a specification for all electrical equipments like a generator, turbine, and we have all specifications. During the contract bidding itself, we show all the specification to the company. If you can follow the specification, then only we'll give the contract, like that the agreement. So they agree that based on that standards, they will design the motor, they will design the turbine, and the design will be supplied to us. Our engineers will evaluate the design and we will ask them to manufacture it. So during manufacture, there are different quality control measures are there. We will go for inspection. Even the material, we will specify that you have to get this standard material like steel. So suppose they are making a runner or turbine, we will ask them to purchase this Tata steel or this type of steel, this quality steel, etc. We will tell them manufacture like this. So in between we have stage inspections, and also finally we have an acceptance inspection. We will give clearance for dispatch. It will be dispatched and received at site. So this is the way After that, we will implement it. We will it's called process. After completing the fitting, we'll again inspect. They have to show all commissioning test. It should work. All things should work properly. Even the panels, computer systems, and other connections, etc. Some work will be there in site also. Some work will be in factory. By that time, the entire civil work will be completed, and we will do the acceptance. So finally, we will do the acceptance testing, called the commissioning testing. After commissioning testing, we will release the final payment. In between, there will be payments according to the agreement. So these are the vague process of an industry related project. So the customer is the king, and as per agreement, they will work for us. So this is somebody asked me to explain how an industry project is working. So because of the time limitation, I just completed in 5 minutes what is happening. So can take some. We can discuss.
Thank you, sir. Am I audible?
Yeah.
Thank you. I'm sure that your words enlightened and inspired all the attendants. Now it's time for us to move on to the question and answer session. So I request all the attendees if kindly post your queries in the chat box with settings as to all panelists for clarifications.
Critical success factors. I guess the question is
See, the critical success factors. Critical success factors will be defined by different firms for their own internal purpose. For example, as far as the project is concerned, a project should complete within time and within budget. This is the basic constraint for any project. So what is happening in government related project? So these two things are violated, and nothing will be completed in time and also in budget. Now we are very strict in budget. Our budget is not increasing, but time we are lacking somewhere. So maybe the critical factors is within time and within budget. So resources will be, most company will consider these two things. So there will be, we will impose fine for delay in executing project. And mostly the budget is over budget, execution will become the headache of the contract company. We are losing production because of the delay in completing the project. So we will give a fine for the company. They have to pay for each day the delay is there. So mostly the company will take as critical success factors as timely delivery of the product and within budget.
what are the various risks in complex construction projects, and how does this integrated project delivery approach help in mitigating these risks?
See, thank you for the question. There are, I was involved in three major construction projects. One is gas in 245 kV gas insulated switchyards, implemented power grid. I was in Hyundai Engineering Construction Company as engineer, and that was during 98-99. So the complex construction there started, the problem started from initial stage itself. It was a reclaimed land and we have to do all the sand piling and other things, and we did all the important, we imported all the items, and this is the first gas sensor switchyards here. So even myself and most of the people, we are not even saw the switch gears, that type of switch gears. So that is very, very complicated, and every construction project is involved a lot of challenges. And anyway, we could complete it. There are challenges during designing, and also during implementation. Many challenges we faced. Anyway, we could complete in 10. We completed the entire erection process in 10 months, and we charged the switchyard. Next, I involved in Palliwas election scheme, but now much work happened during these days because a very delayed project. And Chengulam Pump House is very is a running project and very fast project also. Major problem we faced during many problems we faced. We cannot during design also, like testing also we face a lot of problem because when I went to Calcutta for testing it, there was they lacked the facility for type testing, and so we could again take it to to Bangalore for the heavy, like it is nearly 16 tons. We have to take it to Bangalore for testing it. Again, the landsliding problem is a very critical factor in the project area. Because of this rain, the project is delayed. Again, this flood, the project is delayed by 6 months. Landsliding, another thing, delayed our project.
Next question. How much time would you suggest a BTech project group dedicate to planning of their project? So I guess the question is specifically for planning, or did you mean the whole timeline? I guess it is for planning only, right?
Yeah. So what you can, I will suggest you to make a plan with the MS project. MS project is available. You heard of Gantt chart, no? Gantt chart is a very simple technique we are using in our industry also. So you can, MS project is a software available. So you can do, or other free software you can do with the Gantt chart. This plan I will, so if it is a 4-month project, we can take 1 month.
Planning, maybe they can talk with the guide and take 1 or 2 weeks should.
2 to 3 weeks you can you can
1
do
or
a
2
good,
weeks you can take.
yeah, because the planning is a not a final, you are not going to freeze the plan anyway. The BTech project, you have to revisit the plan again. So you prepare a Gantt chart with the timeline in planning and milestones. So again, you have to do some corrections during your executions. Even working title also, you sometimes you may have to change.
So you need to have a good rapport with the guide also. The guide is a critical factor in planning these projects. Like I said, the depth of the project, the time plan. Will you be able to complete it that by 4 months? Those things you can plan it accordingly with the help of guide only. Talk with your guide. Ideally, planning should be over by taking 2 or 3 weeks. If you are completely dedicating 2 or 3 weeks, it should be over. I guess it's done with that question. Next question.
Open source simulation software,
which are used a lot when it comes to BTech project.
See, ETAP, MyPower, and LabVIEW are softwares, but these are costly softwares. Maybe available with your institution. At least LabVIEW, MATLAB will be available in your institution. These are very good simulation software in power industry. So you can suggest some
for EC, I would say that specifically that lower version, not the higher end versions of Vivado, Xilinx tools. Lower end versions, higher end versions, you may need some license. So during this pandemic situation, many of the companies are offering these tools when you register maybe for 30 days. MATLAB, I'm not sure. MATLAB lower end versions may be available. So Questa Sim, like Mentor graphics tools, they are available for for one registration, it is available for 1 month. You can use that. So during this situation, many of you may have to go for those options. If you specifically log into the company website itself, they are offering these features. Because of this situation, you may have to register using your college mail ID. Those etiquettes are there. So you should be able to do that. Next question. Could you name a few open source simulation? Okay. Next question. Any tips or guidance for forming team with members complementary skills?
See, always you take 4 people will have always complementary skills. So always if you are making a team, it's better to make with complementary skills. Problem is
you need to identify
how you will manage the team, how you will manage the conflicts. So I suggested some interpersonal skills in my slides, how to manage people.
It's a soft skill that you will be learning through your BTech course, final semester.
Yeah, do not worry about the complementary skills of people in the team. It should be a challenge.
Yeah, you have to take up that challenge.
Mimic utility in PowerGrid, ETAP and also MyPower. Even MATLAB also we can model PowerGrid. So in our KSCB we are doing with MyPower.
Any other questions?
See, about electrical vehicle project, I don't know what you are want to know. So there are many projects happening about e-mobility. Even there are companies like Tesla and Mahindra have their own electrical vehicle. So become a product, and you can do some research like mostly the storage is a optimization that is needed. That is optimizing project. So you want optimization in power storage and efficiency. So you can concentrate on using optimization in power storage, etc. So we can, I think, no more questions. So we can wind up. So you want to share? Are you ready?
So if further questions are there, I can share my mail ID. You can email to me also.
So thank you everyone for listening us, spending your valuable time.
Okay, thank you all for
Thank you, sir and ma'am, for your valuable time. With this, we conclude today's session, how to execute successful BTech projects under electrical stream. So thank you, ladies and gentlemen, for your time and patience. We are extremely privileged to have you all here today. I would like to express a sincere gratitude once again to our speakers, Dr. Krishnakumar sir and Mrs. Geethu ma'am, all the dignitaries and the participants for making this session such a grand for a memorable one. Thank you, everyone.
Thank you.